So what we're going to be working on today is perimeter and circumference. We just got done talking about area. So now we're going to talk about the distance around a figure. Okay, so first up, what is perimeter? Perimeter of a figure is the sum of all of the sides of that figure. Again, sum means to add up, so you're adding up all the sides. Okay, so this is the example we looked at before with area. First thing you have to do is identify what are the information I need, what's the information I don't need. In this case, I do not need the actual height because the height is not part of the outside of the figure. So I can go ahead and cross that off as I've done there. Okay, and I don't need that for my problem. So now all I have to do to find the perimeter is simply add up the parts. 12 plus 7 plus 7 plus 8. Add those up in any way that makes sense. For me, I add the 12 and the 8 to make 20. 7 and 7 make 14. Then I add those together. But you can do it however you like. And that's it. Like we said before, notice we both ignored the 6 and also that the measure is units, not units squared. So we have to put that U on there because I didn't define it as inches or centimeters or anything like that. And also be careful that you don't put the squared. The squared talks about squares, which cover area. Also, anything that's area is always a measure squared. Whereas distance around something, distance is units, just to the first power. Alright, so we're going to jump right in. Go ahead and give this one a try on your own. Very simple, so hit play when you're done. Alright, so again, this should be real simple. We're just going to add up all the sides. 4 plus 6 plus 5 plus 8 equals 23 units. Another one to try. Go ahead and pause the video. Alright, so it's not really tricky, but a lot of times people get stuck a little bit on this one because they forget that the sides we don't know on a rectangle are equivalent. So we're going to label, oh, okay, that's a 7 and that's a 10. Now it's as simple as adding up all the sides, which equals 34 units. Double check you're putting that U on there, not just when I say it, but before I say it. Now with a parallelogram, go ahead and hit pause, hit play when you're ready. Alright. Notice here that the 9 and the 4 are the same because also on a parallelogram, our sides opposite are equal. We ignore the 8 because it's a height, it's in the interior of the figure. We don't care about that. We add up 9 plus 9 plus 4 plus 4, and we end up getting 26 units. Okay, one last one to try. Again, the perimeter is about adding up all the sides, and you get 24 units. Now, one thing that could happen here is I could sometimes maybe perhaps not give you the 10. And that's a very common thing is I go ask for the perimeter, and you have to go, oh, wait a second, it's a right triangle. So then I know 6 squared plus 8 squared, and that'll get me my 10 that I can then use to solve the problem. That just takes it up a tiny one more level. Alright, so now we're going to talk about circumference because perimeter is pretty much a form that you've used many times, as really is circumference as well. What you may remember is the circumference is the distance around a circle. We don't talk about sides because circles sort of only have the one side. It's just one big circle. So here's an example. If I have 7 centimeters for my radius, which is again halfway across a circle, my formula is 2 times pi times r. You can also do 2 times r times pi, so the numbers are right next to each other, because as you know, we tend to leave our pi in our answer. So plugging in the 7, I go 2 times 7, which equals 14 pi. I do use centimeters on this one because the problem talks about centimeters. So that formula, 2 pi r, or 2 times pi times r, is a very important one to remember as we go forward. Okay, so this time there's a diameter on this problem. So what do we do here? We go ahead and cut that in half. So we have to remind ourselves that 18 is all the way across, therefore 9 is halfway across. So plugging it in, we're going to get 2 times 9, which is 18 pi. Another formula that sometimes is used by teachers is pi times d, which is pi times diameter. I just prefer to use 2 pi r and always think about you always need radius for circles. That way you just always, use it. You think, what's my radius, what's my radius, what's my radius, rather than trying to remember when you use diameter or when you use the other. So it is pretty simple, so I'm not going to have you practice any of those because you've seen them all before. What I am going to have you guys practice is I want you guys to go ahead and practice and learn about what we're talking about, a piece of a circle. So before we learned that a sector is a piece of an area, well, an arc is a piece of the circumference. So for example here, there's my 30-degree angle. If I were to fill that in, I'd be finding the area of that sector. Instead, what I'm going to do is I'm going to look at just that piece right there. And that represents an arc. When we find the distance, it's called an arc length. So that piece is an arc, and what we're going to do is we're going to find the arc length. So remember our formula from before. It's actually pretty much the same. What we're going to do is we're going to have this time, what is the fraction of the circumference that we have? So our sector is 30 degrees, that goes on top. We know the whole circle is 360, that goes on the bottom. And it's actually, if you look at it, it's just the way before. So given a circle with an angle measure, you should be able to find both the area of that sector and the arc length on the circle. So that goes ahead and that equals 1/12. So from there, we would go ahead and simplify and get 2/12 or 1/6 pi r. The reason I leave it separate is because what I think is the best thing to do, instead of trying to take that 2 and simplify the fraction every single time, is to find the circumference of the whole circle and then figure out what fraction of it you're talking about. I think that's just an easier way to do it. So in this case, we would go ahead, if we were solving this problem, and figure out what this is right here. And then we would go ahead and take it and apply it by dividing by 12 or multiplying by 1 and dividing by 12. So let's go ahead and try a few. The first one we're going to try is to find the length of this arc. So if you want to, go ahead and pause it and give it a try. I mean, if you have trouble with it, you can go ahead and watch the video from here on. Okay, so we're going to first set up our sector on top and our hole on the bottom, which is 60 over 360 times 2 pi r. We're going to substitute in our pi, first simplify that to 60 over 360, then substitute in our radius. Okay, now 2 times 6 is 12, so that's going to be on top and 6 on the bottom. Obviously 12 divided by 6 is 2 pi. So if you look at it that way, the whole circle is 12 pi, 2 times radius times pi, and we want only 1/6 of that, which is 2 pi. Okay, go ahead and try this one. Pause the video, give it a shot. Alright, so again, we want to set up sector on top, the degree of the sector and the degree of the hole. So 45 over 360 times 2 pi r. 45 over 360 simplifies out to 1/8. Our radius is 4, so we end up with 2 times 4 is 8 on top and 8 on the bottom. And the final answer is pi inches. So obviously this is a quick thing, very, very quick video. And what I want you guys to do is just go ahead and fill out the survey below so I can know if you had any confusion over this. And understand that from now on we're going to be practicing finding both the area and circumference of sectors as well as whole circles. And that's going to be something that you're expected to be able to do as we continue forward with the class. So go ahead and fill out the form, and I'll see you tomorrow.